Hello friends, welcome to our channel. Let's revisit problem 652, find duplicate subtrees. In this video, we're going to solve it using recursion. Actually, what I want to emphasize is that this problem can be regarded as one of a series of problems that's related to serialization and deserialization of data structures. So the data structures can be binary tree, a linked list, or just a plain list. So here, actually, for this problem, the main point is that we need to distinguish the examples here. So these three trees are actually structurally different, right? So here, the first one, you have three nodes, one root node, left subtree, right subtree. So if you just put things together, you get 1, 0, 1, 2 as a string. And typically, for the second one, so you have a left subtree with value 12. You also have this one. And the third one, you have a right subtree and with 0, 1, 2 as a string. So we want to distinguish this case. This is the one thing. Another thing is that we also need to do the counting in the same time. This is another trick we can use. So for this video, what I'm going to do is to explain something related to argument pass in Python. So we all know that Python is passed by reference. Let's see what do we mean by this. So first, I'm going to initialize a count. It's collections counter, right? So this is one way. Or you can do this count collections default dict. So you can initialize as int. Both are okay. Let me see comment one. So then also I want to initialize a result variable. So this the final state of it is what we want to return. And next I'm going to write a recursion function. Let's call it DFS from a node. And then what I want to do is to call this DFS function from the root. And then I'm going to return the state of this result. So this is the overall structure. So now let me write this code and then explain what do we mean by pass by reference. So here, this function will modify these two variables. So typically, due to the scope, variable scope, you need to do non-local count and result. However, due to the fact that the count and the result are both mutable, you don't need this line. However, if you have another variable which is immutable, for example, you have an integer x, then you need to use this one, right? So in other words, if you have something you want to alter outside this function, and then you need to use non-local keyword if those variables are immutable. Otherwise, you don't need this one. So because here, these two are mutable, I don't need to use non-local. So then I'm doing this. If not node, I'm going to return an empty string. This empty string can be regarded as a encoding for the tree. Otherwise, after this if check, I can do this. DFS node left, right? DFS node right. Because if there's no left subtree or right subtree, this will correspond to empty string respectively. And then I'm going to encode this. Here I can use in-order traversal. But in order to do this, I just use this f string, right? So I have a left character, so I use this left tree. This actually is some digits, some L, some stars, right? I can use this. And node value. And then we have a star, and then we have red, and then we have this red. And then we're going to increment the count of this s by 1. So if count s equals 2, so only when it first touches 2, we are going to count that. So we're going to result append this node, and then we return the encoding of this tree. So this is a hyperfunction. So the hyperfunction will modify these two variables, count and result. So then we can call this function, right? It does several things. Then you are going to get the result. Let me first run it. It passes the 3 test cases. Now let's look at the generic case. Yeah. it passes all the cases. So here, let me make some comments. First, there's one point. So when you use a subclass of dictionary in Python, you can use this one, or you can use this one. Let me comment this one for this problem, so you can submit that. And also, you can use a third option. Let me also copy this one. So you can do const collections default dict. You can first map everything to be 0. So this also works. Let me submit. Right. So this is the one thing. Another thing is about the encoding. So here I'm using this the in between. This is the in order traversal. So if I add this one in the front or in the end, let's see what we get. So this will be, say, node value, put a star here. This will be pre-order traversal, right? So now let's submit that. It works. And also, if you, I cannot use this cut. Let's see how I can do that. Let me put it in the end. Node value. This corresponds to post-order traversal. It will also work. This is the second point I want to make. Another point I want to make is the way we write the code. We are using essentially the feature of the language, that is pass by reference. So because these two variables are mutable, so I don't need this non-local count and the result. But if you add this line, it still works, but redundant. Let me submit that, right? So this is another comment. I guess with all those, that should be sufficient. One last point I want to emphasize is that you can follow up other videos so related to serialization and deserialization. So the serialization and deserialization is not only a way to persist some data, it's also a way to solve problems like here, right? So with that said, I guess that's all for the current video. Thank you for watching.